Welcome to the first ever Calibration House webinar. Today we're going to address a question that numerous customers of ours have asked us over the years, and that's UKAS or traceable calibrations. How do I choose the right option? What are the differences? So the agenda for the webinar, we're going to do an introduction to Calibrationhouse, who we are, what experience we have that lets us advise people about the differences between calibration done to UKAS level or to a traceable level. What is calibration in the first place? What's involved? What standards calibration adheres to? And the calibration options. Finally, we'll look at some practicalities of calibration. So the format of today's presentation, well, this is a recording, but we have a live question and answer session at the end. During the presentation, please feel free to use the chat section on screen to ask any questions you might have, or you could ask them at the end of the presentation. You can obtain a copy of this presentation by going to the handouts section of your GoToWebinar control panel, or you can request a copy afterwards. So Calibration House, who are we? Well, Calibration House is a Seaward brand, much like Rigel Medical. Seaward Electronic is our company. Calibration House is our brand. We have been calibrating in the UK for 40 years, and we've had continuous UKAS accreditation for the last 16 years. Our UK site is based in Peterlee in Durham, and we have a US site in Tampa, Florida. But we don't just calibrate our own products. We've calibrated over 8,000 individual models from over 1,000 different manufacturers across 6 of the 7 calibration disciplines: flow, temperature, electrical, humidity, pressure, and dimensional. Calibration House is trusted by some very prestigious organizations. We work with over 90 NHS trusts, Oxford University, Dyson, Travis Perkins, Fujifilm Healthcare, Bosch, Ocado, St. John's Ambulance, Metla Toledo, Siemens Healthcare, Nissan, and Next, to name a few. So, what is calibration? Calibration answers the question, is my measuring device accurate? It's the process of checking a measuring instrument to determine if it is accurate compared to standards held at national or international metrology institutes. It's not an adjustment, as many people believe. The reason this misconception exists is because often the calibrating company will adjust the unit back to accuracy for free. So how does calibration work? You compare measurements for the instrument under test to more accurate equipment. A calibration certificate is produced that is unique to the unit under test. This certificate details the differences in readings between the two devices, which is known as the error. And this is subject to the uncertainties of measurement. There is an unbroken chain of calibration that leads back to a national or international standard. So we'll take the kilogram as an example. Somewhere in the world, there is an official kilogram. Now, the definition of the kilogram actually changed recently. The original kilogram had lost approximately an eyelash worth of weight or mass over time. So it has changed to a more accurate way to measure a kilogram. So Google that if you'd like to learn more. So you take a copy of the official kilogram and you compare or calibrate it against the official kilogram. There's then a copy of the copy, which is compared or calibrated against the first copy. That is known as your local standard. You take your local standard, your kilogram, and you can use this to calibrate scales subject to the uncertainty of measurement. Now, are you uncertain about uncertainties of measurement? This is defined as the doubt that exists about any given measurement. It is statistically derived, taking into account all factors that could affect the calibration process. These are normally environmental, so it can be temperature, it can be humidity. So for the 3 different kilograms that we just discussed, you might have an uncertainty of measurement for your final kilogram of 0.2 milligrams plus or minus, which you can then take into account when looking at your readings. To give some wider context, we have SI units. Now, these are more commonly referred to as the metric system, and they're the basis for modern calibrations. SI stands for Systeme International, and we have the meter, M, which is our unit for length. We have S, which is our second, and that's our unit for time. We have the mole, and that's our unit for the amount of substance. We have A, which is the ampere, which is our unit for electric current. We have K for Kelvin, it's our unit for temperature. We have CD, or candela, which is our unit for luminous intensity. And we have kilogram, which is our unit for mass. Now, the SI units were chosen as they're considered independent of dimension. The kilogram is actually the last standard to still be tied to an actual object. To give you an example of this, the meter is the length of the path traveled by light in a vacuum during a time interval that is really tiny, a really small proportion of a second. To give another example to try to understand measurements of uncertainty, think of a ruler that has 32-inch divisions. While you can guess where a measurement might fall in between the divisions, you only really know down to 1 in 32 parts of an inch. If your ruler had more increments, if you could measure to smaller increments, you'd have a smaller measurement of uncertainty than 1 in 32 parts of an inch. And as I'm sure you all already know, it's got to be in your diaries already, we have World Metrology Day coming up on the 20th of May 2023, where the advances in measurement science are celebrated yearly. That's the link if you'd like to learn more. So who calibrates for the calibrator though? So calibration companies should send their equipment away to third parties for independent verification that their calibration equipment is accurate. Now we move on to the standards and options section. So you'll often hear the term ISO and UKAS interchanged. So what is ISO IEC 17025? So ISO is the international organization that writes industry standards, i.e. they write the rules. ISO/IEC 17025 is the industry standard specifically for calibration. So then what is UKAS? UKAS stands for the United Kingdom Accreditation Service. UKAS oversees the ISO rules. Now UKAS, even though it's the United Kingdom Accreditation Service, is recognized internationally by bodies such as the European Cooperation for Accreditation, or the EA, the International Laboratory Accreditation Corporation, ILAC, and the International Accreditation Forum, the IAF. So UKAS is an international accreditation body that ensures competence, impartiality, and integrity of testing and calibration laboratories through independent assessment to the ISO/IEC 17025 standards. So what is UKAS calibration? This is defined as a calibration that is performed to international ISO standards by an accredited third party, for example, Calibrationhouse. This gives you peace of mind that your calibration has been performed to a high standard by a trustworthy laboratory that has had its processes and personnel audited technically by UKAS. So what is a traceable calibration then? This is a calibration performed by an unaccredited third party. They haven't been assessed technically, their staff have not been assessed, their processes have not been assessed. It is traceable to national standards because they can use test equipment that has been calibrated by a UKAS accredited company. For example, a weighing company would have their test weights UKAS calibrated, and then it is a traceable calibration, but their processes and their personnel have not been assessed and audited. A UKAS and a traceable certificate will have certain differences. With a traceable certificate, you won't see the UKAS logo. This is the most obvious distinction between a traceable and a UKAS certificate. If you see the UKAS logo or symbol, which you can see in the second image here, the second example, that tells you that the certificate is a UKAS calibration. If that logo isn't present, it's not a UKAS calibration. A UKAS certificate will also have the environmental conditions listed. So you can see here, temperature and humidity were within the tolerances that are acceptable for a UKAS calibration. A traceable certificate normally doesn't have this information. A UKAS certificate also has a method statement and a UKAS statement. So the method statement is explaining how the calibration was performed, and the UKAS statement is stating that the certificate is issued in accordance with the UKAS accreditation requirements. A traceable certificate obviously wouldn't have the UKAS statement. It may have a method statement, but not normally. A UKAS certificate also has a statement showing which compliance rules have been followed to determine if the equipment is in compliance with the specification. How has compliance been determined? This is better represented here with a graph. So you can see that your nominal value falls in the center. You've got your two specifications, the two ranges, upper and lower, and then you've got your measurement uncertainty either side of that. And this is explaining how the compliance rules are followed to determine if the equipment is in compliance with the specification. A UKAS certificate generally has more readings that include measurement of uncertainty. So you can see the uncertainty of this electrical calibration on the right-hand side here. Traceable certificates tend to have fewer readings and they don't include measurement of uncertainty. A traceable certificate must demonstrate how it is traceable. So you can see here a list of equipment with the relevant certificate numbers. So this is the calibration company's equipment, showing that their test equipment has been calibrated to, in this instance, UKAS. And therefore, when they use that equipment to calibrate a customer's equipment, the calibration is traceable to UKAS through the calibration company's test equipment. So what are the differences between traceable and UKAS? So Are they traceable to national standards? Yes, both are. Are they traceable to international standards? UKAS is, but a traceable calibration is not. It's only traceable to national standards. Is the certificate that is produced an internationally recognized legal document? Well, for traceable calibration, no, it isn't, but it is in UKAS. Is the lab equipment used to perform the calibration UKAS calibrated? It usually is for traceable, and it definitely is for UKAS. Does the lab performing the calibration have an ISO 9001 certified quality management system? For a traceable calibration, it usually does, but not always. For UKAS, it must. ISO 9001 is a different ISO rule that governs a quality management system of a company. Are calibration procedures assessed by an independent UKAS accreditor? Well, for traceable calibrations, no, they're not. But for UKAS, yes, they are. Are lab personnel assessed for technical competence by a UKAS accreditor? For traceable calibration, no, they're not. And for UKAS, yes, they are. So what are the common reasons why you would choose a UKAS calibration over a traceable calibration? The first one could be safety. So when the measurement results are critical to the safety of a product or a process or a person, then it's wise to choose the higher quality UKAS calibration option. Regulations can dictate the choice. So highly regulated industries may demand UKAS quality level. For example, automotive, pharmaceutical often demand UKAS calibrations in their regulations. Quality, you may not be dictated by regulatory bodies, but your company may wish to demonstrate the quality of their products or service by having a strict quality management system that demands UKAS as part of your company's approach to high quality. Other reasons, your customers, your supply chain may demand that you have UKAS calibrations to assure the quality of the goods they receive from you. And international trade can benefit from UKAS calibrations because UKAS is not just a UK body, it's internationally recognized. A UKAS calibrated product demonstrates quality on a worldwide basis. Another question that people ask is, how often should we calibrate? There is no strict answer to this question. Calibration is the equivalent of peace of mind. Is my device accurate? The frequency of your calibration is how important is that peace of mind. The most common choice is 1 year. Some customers will choose to have their equipment calibrated more often if it's considered critical. You have to think, what would be the impact of incorrect measurement for a quarter, for 6 months? What impact would that have on your company, your customers, your products? And that's how you decide how often you should calibrate. Next, we'll look at the practicalities of calibration. Often the unit that needs to be calibrated is crucial to an organization's processes, its measurements, its checks, and they can't bear to be without it. They don't have a spare unit, and they can't afford for it to be away for weeks at a time. Here at Calibration House, if a unit must come off site, then we have a 5 working day turnaround time. We perform the calibrations in our state-of-the-art laboratory in Durham that was renovated in early 2022. Alternatively, and wherever possible, we can bring our calibration lab to a customer's premises. Our engineers can attend anywhere in the UK and Ireland, and they bring all of the equipment required to perform the calibrations on site. They just need space and power and the units requiring calibration, and that means there is very little downtime for the customer. The calibrations are completed and the unit goes straight back into use. In either scenario, we pride ourselves on our service, and ensuring the customers have peace of mind that their equipment is performing well and is accurate, and that they have everything they need for any audits. So that brings us to the end of the webinar. It's time for you to ask us any questions that you might have. Please type them in the chat box.